What is the domain of y equals cosecant x? So this is an indirect way of simply asking us what the asymptotes are, because the domain will be all real numbers except for the asymptotes. So let's find the asymptotes of cosecant. So first of all, remember that cosecant is the reciprocal of the sine function. So this is really what cosecant is. So because it is the reciprocal of the sine function, whenever we ask ourselves what cosecant is doing, we must first start by picturing the sine function. Alright, so let's do a little graph starting with the sine function. Alright, so this will be 2 pi and pi over 2. Sorry. This is pi, and this will be pi over 2, and this will be 3 pi over 2. And the sine function goes like this. It starts at the midline and goes up, back to the midline, and down, and then back to the midline. So this is what the sine function looks like. Okay. Now, because you cannot divide by 0, that means we're going to have an asymptote everywhere the sine function is 0. Alright, that means we're going to have an asymptote everywhere the sine function touches the x-axis. So we're going to have an asymptote here at 0, and then we'll have another asymptote here at pi, and then we will have another asymptote at 2 pi, and it will repeat like that. Alright, let's come up with an expression for that. So we started at 0, and then the next one happened pi later. Okay, and because this is a periodic function, it repeats. So every pi, we're going to have another asymptote. So 1 pi, 2 pi, 3 pi, 4 pi. So we can say n pi to represent that we're going to have an asymptote at every multiple of pi. And since this is just 0, we don't really need it. So I'm just going to erase the 0. So this is an expression representing where all of the asymptotes are. Okay, the asymptotes are at n pi. So that means the domain will be all real numbers except for n pi. So that's what we're looking for. So here it is, all real numbers except n pi, where n, of course, represents an integer like 1, 2, 3, and 4. Alright, so this should be the answer. Let's just check our work, and that check mark means we've got it.